Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be looking at question 19 from the coverage of grade 12 elite. This question from the coverage has the highest number of suggested questions from AP Classroom. So what I am going to do in one or two videos will not be enough. So you have to practice all the provided questions. So the first question here says, let R be the region in the first quadrant bounded by the graph of y equals 2 square root of x. So this is the first piece of information that we have. This function is y equals 2 square root of x. And the horizontal line, this is the horizontal line, y equals 6. And the y-axis as shown in the figure. In the first part, we need to find the area of region R. So finding the area in part A, we need to find the area. So the area, one second. So the area equals okay, so the area equals the integral from 0 to 9. This number over here is 9. So the area from 0 to 9 of upper minus lower. What is the upper function? The upper function is 6 minus what is the lower function? The lower function is 2 square root of x dx. So let's evaluate this integral. First we can rewrite square root of x. So this is 6 minus 2x to the power of half dx. Now we can say that the area equals 6x minus 2x to the power of, and when it becomes 3 over 2, divide by 3 over 2 or multiply by 2 over 3. And this is evaluated from 0 to 9. So the area equals 6x minus 4 over 3, x to the power of 3 over 2. Evaluated from 0 to 9, 6 times 9 minus 4 over 3 times 9 to the power of 3 over 2 minus 0. If you plug in the 0, it will be 0. So this is equivalent to 18. So the area of region R is equal to 18. That's the first part. The second part is right, but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. So this is a washer method revolving around other axis. So this axis of rotation is parallel to the x-axis. So this is the axis of rotation, y equals 7. And this is where the region is being rotated. Now, for part P, okay, so for part P we need to find the volume, and as long as it's something being rotated, we should multiply by pi. Do not forget the pi. Times the integral. The integral goes from 0 to 9. Along the x-axis, it's from 0 to 9, of r capital minus r small squared, right? So here we have, this is r small, and this is what? This is the r capital. So the bigger radius is the difference between the function and y equals 7. So we can say 7 minus the function, which is 2 square root of x. This is all square. This is the bigger radius, r capital. Now minus r small will be constant. It's the difference between the two horizontal line y equals 7 and y equals 6. So it's 7 minus 6 all squared dx. So you can just replace 7 minus 6 with 1, or you can just leave it like this. It says do not evaluate, just write the integral. Now for part C, let's just erase this. Let's erase what we have done here. Now in part C, it says region R is the base of a solid for each y, where y is between 0 and 6, including 0 and 6. The cross section of the solid taken perpendicular to the y-axis. So this is a key phrase here in this question, perpendicular to the y-axis. And each cross section is a rectangle whose height is 3 times the length. Now, this is called the slicing method, where we have given a cross section perpendicular to the y-axis. So the shape of the cross section here perpendicular to the y-axis. So this is a cross section, and it is what? It is a rectangle. Now the length of this rectangle is the function, but written in terms of y, and we have to isolate x. So let's isolate x. We have y equals 2 square root of x, divide by 2, divide by 2. Y over 2 is equal to the square root of x. Raise both sides to a power of 2. You will get x equals y squared over 4. So this length here is equal to the function, which is y squared over 4. And the width, the question is saying that the width, or I flipped them. Let's say this is width and this is length, better. So this is the length, sorry. This is the length and this is the height. And instead of using length and width, let's keep it length and height. Now the height of this rectangle is 3 times the length. So it will be 3 times y squared over 4. Now, the volume is given by, there is no pi here, okay? The volume is equal to the integral from 0 to what? From 0 to 6, because we are writing an integral in terms of y, dy, so we have to select y values. So we are going from 0 to y equals 6 here, okay? Of the cross section, the area of the cross section. What's the area of the cross section? It's length times height dy. So it will be the integral from 0 to 6. The length is equal to y squared over 4 times the height is 3 times y squared over 4 dy, which is equivalent to the integral from 0 to 6. 3 over 4 times 4 is 16, y squared times y squared is y raised to 4 dy. That would be the answer for part C. I hope that was short, helpful and clear for everyone. So we did part A, the area, part B is the washer method, and part C is the slicing method or the cross-section method. So good luck.